All right, so I'm going to show you some terminology first, and then we'll go on MathLab and actually do 8.1. So 8.1 support deals with polynomials. And y'all, polynomials are just expressions that are made up of one or more terms. And the terms of a polynomial are separated by your addition and subtraction. So the first thing we'll learn about is what we call the leading term. So y'all, the leading term of a polynomial is the term that contains the highest exponent. Okay. Now the leading term is made up of the number, the variable, and that exponent, okay? So then we look at what we call the leading coefficient. So the leading coefficient is the number in front of the leading term. Now remember, if your leading term is something like x to the fifth, and there's not a number in front of it, we always treat that number like a 1, okay? So that would be like a 1x to the fifth. All right, y'all, and then the next word we learn is the degree. So the degree of a polynomial is actually equal to that highest exponent. So this is equal to the highest exponent. Of the polynomial. Okay, so all of these are found inside the leading term. The leading term will have the leading coefficient, be the number in front of the variable. The degree is equal to the exponent of that variable. Okay, and it's got to be the highest exponent. So all of those are going to be found inside that leading term. Now we look at what we call the different classifications of polynomials. So these will be the classifications. So I'll look at the different classifications. We'll look at what their degree is. And then I'll do an example of each. So first, we got what we call a constant polynomial. So to be a constant polynomial, it'll have a degree 0. And an example would be f of x equals 7. So if your polynomial is one term and it's just a number, it'll be what we call a constant polynomial, and it has a degree 0. Next, we got linear. Linear is a degree 1 polynomial, and that'll be like f of x equals 2x minus 3. It's got two terms. Now remember, since there's not an exponent shown by the x, that exponent would actually be a 1. So that's where we get that degree from, okay? Exponent of 1. All right, y'all, next, quadratic. And we've been doing a lot of quadratics, and those are the x squared graphs. So they have a degree 2. So an example of a quadratic could be 3x squared minus 7x plus 5. Notice I got 3 terms, 3x squared, negative 7x, and a 5. The leading term is the 3x squared. Lead coefficient is the 3, and then the degree is the exponent of a 2. All right, next we got cubic. A cubic polynomial has a degree of 3. And an example would be something like f of x equals 8x to the third minus 27. This would be a 2-term polynomial, but the leading term is the 8x to the third. Lead coefficient is the 8, and the degree is equal to that exponent of 3. And y'all, one more we got is quartic. So quartic would be a degree 4. And an example of a degree 4 would be something like 7x to the 4th plus 5x third minus 2x plus 1. This would be a 4-term polynomial. The leading term is 7x to the 4th. Lead coefficient is the 7, and it has a degree 4. Okay, so all these classes are looking at the highest exponents of these to get their degree. All right, y'all. So we want to know this because we're about to do the support examples, and they're going to ask us what's the leading term, leading coefficient, what's the degree, and then what's the classification. Okay. So here we go. We're going to switch over to Math Lab. All right, y'all. So here we go. Whoops, hang on. Let me get on the right one. All right, support for 8.1. Here we go. So they want me to determine the leading term, the leading coefficient, degree of the polynomial, and then we will classify it. So y'all, I'll knock out one, and then I'll have y'all start helping me on these. So for my number 1, the leading term is the negative 1/6 x to the 4th. So negative 1/6. And then I had what? X to the 4th. So the leading term is everything in the term that has the highest exponent. So it'll have you check that. Then it wants to know what's the leading coefficient. Well, remember, the leading coefficient is the number in front. So that'll be the negative 1/6. So we'll punch in the negative 1/6. Check that answer. The degree of my polynomial is equal to the highest exponent, which is in the leading term. So mine is a degree 4. And then the type of polynomial, well, remember, we said if it was the degree 4, it was quartic. And we would check that answer. All righty, y'all. So this polynomial, negative 4x minus 8. There's not an exponent by the x, so we would treat it like a 1. And to have an exponent of 1 as your degree makes this thing linear. So remember, those are like straight lines, so that's where they get that linear from. The leading term, well, that's going to be the negative 4x. The leading coefficient, well, remember, that's the number in front of the leading term, so that's going to be negative 4. And then the degree of my polynomial is 1, because that was the highest exponent on this one. So y'all, one more of these, and then we're going to get into 8.1 college algebra. So what do y'all think on this one? Negative 3x to the third minus 9. Is that linear, quadratic, constant, quartic, or cubic?
Cubic.
So definitely cubic. So we're going to check that. So what is your leading term?
Negative 3x3.
There you go. Perfect. Leading coefficient?
Negative 3.
Negative 3. So it looks like you're ready for these homeworks. And then the degree?
3.
3. Perfect. All right, so good job on that. So now I'm going to get us back to the pad for more definitions. And y'all, that's all support was doing was mainly support just wanted to get you all those definitions so that you would know what a lead coefficient was and what a degree was. So when we do this here, college algebra, okay? So this is going to be the 8.1 college algebra, and it deals with polynomial functions. So the first thing on these polynomials, we're going to look at what we call the end behavior of the graphs. So what they mean is, what's the graphs doing as these x's go towards negative infinity and infinity, okay? So graphs with even degrees are similar, and then the graphs with the odd degrees are similar. So we make a chart that'll help us predict what the ends of the graphs are going to look like. And y'all, I call this the end behavior chart. Now this chart will be good for 8.1 and 8.2 because 8.2 will have some graphs, and we can use this chart to sort of predict what they'll look like also. So the chart looks at the degree first. Now with the degree can be even. So I can have an even degree, or I can have an odd degree. Okay, so it looks at the degree. Is it even or odd? And then we compare that with the lead coefficient. And we're only looking at the sign of the lead coefficient. But the lead coefficient can be either positive or negative. So y'all, that's going to separate us into 4 categories on here. I'll have an even degree, positive lead coefficient. I'll have an even degree, negative lead coefficient. Then I'll have an odd degree, positive lead coefficient, odd degree, negative lead coefficient. Okay, so if your degree is even and you got a positive lead coefficient, both ends of the graph are going to point uphill. So just like the parabolas we were graphing, when we graphed those parabolas, both sides went uphill when it was positive. Now, the reason they leave these little spaces in here is because if this was a degree 4 or a degree 6, there's going to be a lot more terms inside here. But as the x's get bigger and bigger, it's going to head towards positive infinity. Now remember, on those x squared graphs, if we made the lead coefficient negative, it took them graphs and flipped them. So if you got an even degree and a negative lead coefficient, both ends of your graph are going to point down. Okay, so even degree will either have both ends going up or both ends going down. So then we look at the odd degree. So y'all, if it's odd with a positive lead coefficient, that graph is going to go uphill, left to right. And once again, depending on the degree, determines how many turns it's doing inside that. But in the long picture, it's going to go uphill, left to right. Now, if I'm an odd degree and my lead coefficient is negative, it's going to flip this over. And instead of going uphill, it's going to look like it's going downhill, left to right. So, y'all, that's the 4 things that can happen with these polynomials. Even degree, both up or both down. Odd degree is either going to go uphill or downhill. So let's see, I believe the first 4 in Math Lab, we'll look at this, and then we'll start playing with what we call zeros. So I'm going to take us to Math Lab, and y'all remember this chart real quick. All right, so y'all, they want me to know which one of these 4 sketches I'm going to use that'll describe the end behavior of the following graph. F of x equals square root of 7 x to the third plus 2x squared minus 4x plus 4. So first of all, I need to figure out, is my degree even or odd? Well, I got a degree 3 here because that's the highest exponent. 3 is odd. So this graph will either go uphill or downhill because of that odd degree. So then I'm looking at that square root of 7. That square root of 7 is positive. So since I got a positive lead coefficient and an odd degree, my graph is going to go uphill from left to right. So on that one, I would choose D. So you put your D in, check your answer. So y'all, I'm going to ask y'all this one, A, B, C, or D. You got P of X is a negative pi x to the 6th plus x to the 5th minus x4 minus x plus 9. So y'all got an even degree with that 6. You've got a negative lead coefficient with that negative pi. So if it was even and negative lead coefficient, did I go with A, B, C, or D? So y'all let me see my chat. So Hannah A, that's what I'm going to go with also. Because remember that negative's flipping it over. So we're going to go with A, and then you check that answer. Now y'all watch out. Sometimes they put them out of order. This one's got f of x equals negative 3.4 x to the 4th plus x to the 6th plus 0.9 x to the 7th. So this is the degree 7. It's just out of order. So 7 is odd. So we got an odd degree. That 0.9 is positive. So you got an odd degree, positive. So let's see what the chat's saying. So let's see, would that be C, uphill, left to right? Good job. All right, y'all, one more of those. 8 plus 1/8 x to the 4th minus 1/5 x to the 3rd. So let's see what y'all get up here. I got my chats rolling. So D, let me see. So D is even and positive. Good job, y'all. Even degree with the 4. 1/8 is positive. So that would definitely be D. All right, y'all. So I'm gonna go back to my pad now. But yeah, the first 4 of those, that's basically all you're doing is looking at your degree and then seeing if that lead coefficient's positive or negative. Then we get into zeros. So they want us to use substitution to determine whether 4 is a zero of f of x equals x to the 3rd minus 9x squared plus 15x plus 20. So here's the thing. Remember, zeros are solutions to the quadratic equations or the polynomials when we set these equal to 0. So that means if 4 is going to be a 0 of this polynomial, when I plug it in for the x's, I got to get a 0 for the answer. So that's what it means to be a 0, is when I plug it back into the function, do I get a 0 out of that answer? Okay. So if 4 is going to be 0, we're going to plug a 4 in. So we'll be finding f of 4, which will be 4 to the 3rd minus 9 times 4 squared plus 15 times 4 plus 20. All right, y'all, let me let one in real quick. So I plugged the 4 in for the x's. Now I either get a 0 for my answer, which makes that a yes, or I get any other answer, I'll put no. So this one, they'll just have a yes or no answer for you, okay? So 4 times 4 times 4 is 64. Minus 9 times 4 squared. 4 times 4 is 16. And then I'm just bringing everything else down, y'all. So only thing I did on that step was did the 2 exponents. I did the 4 to the 3rd and then this 4 squared. Now I'm going to go and multiply this 9 and 16 and then that 15 and 4. So bring down my 64 minus 9 and 16 is 144. Plus 15 times 4 is 60. And then plus my 20. All right, so adding and subtracting left to right. Let's see what we get. 64 minus 144 is negative 80. Negative 80 plus 60 is negative 20. And look at that, negative 20 plus 20 gives me a 0. So since I got a 0 when I plug the 4 in, that would be yes, 4 is a 0. Okay, y'all? And we're just showing you this so that when you find zeros, you can check them by plugging them in and see what you get. If you think you got a zero and you plug it in and you get 0 for the answer, then that confirms it is a 0. Any other number, member, means it's not a 0, okay? So before we continue on, we're going to learn some new words. Well, one new word. And this word is multiplicity. So y'all, the multiplicity, that's the number of times that a 0 occurs. Now, these multiplicities are equal to the exponents of each factor. So they're equal to the exponents of each factor. Okay. Now, a couple more things these multiplicities tell me. If I got a factor and it's got a even exponent, so even multiplicities so if it's an even multiplicities, the graph is tangent to the x-axis at that 0. So the graph is tangent to the x-axis at that 0. So y'all, what I mean by tangent, let me just draw me a little graph here. So what I mean by tangent is that the graph will come down, sort of touches that x-axis, and then it'll curve back up. It does not cross over it. It just sort of comes down and touches it and turns back up. That right there is what I mean by tangent. Okay. Now, odd multiplicities. Well, if it's got an odd multiplicity, the graph is going to cross over the x-axis. So the graph crosses over the x-axis at that 0. Okay, so let's see if we was looking at that. So say I had a graph coming down, it would cross right over that x-axis, okay? So the factors will give me the zeros, but those exponents tell me whether it's crossing over or if it's going to be tangent to it. So later on, they'll have a couple true false that we'll do this data with, okay? All righty, so for these examples, we're going to find the zeros of the polynomial and state the multiplicity of each. So these start around number 6, one I'm about to do. Number 6, they're giving me f of x equals parentheses x squared minus 16 to the third power. So here's what's happening. The x squared minus 16 is my factor. The 3 out here, the 3, remember we said the multiplicity was equal to the number of times that a 0 occurs. And we said it's equal to the exponent of the factor. Well, there's the exponent of this factor. So this 3 is going to be my multiplicity. Okay. Now the x squared is the factor. So to find the zeros, we're going to take this factor, x squared minus 16. And y'all, we're going to set it equal to 0. Remember, everything in college algebra, we always set equal to 0 in this class, okay? Now, that x2, exponent of 2, that tells me I'm going to get 2 zeros out of this equation, okay? So if an exponent is on a factor, that tells you how many zeros this is about to give us. So y'all, to solve this, the quickest way would be to add 16 and do square roots. So I'm going to come in here, add 16 to both sides. I get x squared equals 16. Then we want to do a square root to each side. So y'all, let's see what we get. Square root of x squared is x. So y'all, I need the square root of 16. So let me see what my chat's got going. All right, so Hannah, you got one of them. I need both of them, remember? Oh, y'all done forgot. Remember, when you take a square root, you're going to use what? A plus or minus, and then the square root of 16 is 4. So remember, y'all, square root of 16 is 4, because 4 times 4 is 16, but it's also negative 4. Negative 4 times negative 4 gives you 16. So y'all don't forget, square roots, we got to get both the positive and negatives on those. So y'all, your zeros are going to be plus or minus 4. Each has a multiplicity of, well, y'all, that exponent out there is my multiplicity. So each one of them has a multiplicity of 3. And y'all, that's because if you was to write this out, you would get an x squared minus 16 times the x squared minus 16 times x squared minus 16. So that's what that 3 is doing to this. And then that's why if you solved every single one of those, you get the same answer 3 times. Okay, so let me try number 7 here. So the same thing, y'all. This time I got f of x equals x to the 5th, x minus 5 squared, and then x plus 7. So notice I got 3 factors. I got the x minus 5, and the x plus 7. So since I got 3 factors, I'm going to set each of my factors equal to 0 to find my zeros. Then once I find my zeros, I'll figure out their multiplicities. Now y'all notice this. Anytime you got a single x like this with an exponent, well, it's always going to equal 0. Okay? 0 times 0 times 0 5 times is 0. no matter what that exponent is, if it's a single x, it's always going to equal 0. Now the second one, I got an x minus 5. So I'll solve that by adding 5. So I got a 0 of 0, a 0 of 5. And then my last one, I will subtract 7. And I get -7. So notice the factors and the zeros always have opposite signs. That was -5 factor, gave me a 5 as a 0. So y'all look how they do this answer. They say the smallest 0 is blank. It has multiplicity blank. Then the middle 0 is blank. It has multiplicity blank. And then the largest 0 is blank. It has multiplicity blank. So what we got to figure out is which of these numbers is the smallest, 0, 5, or -7. Well, y'all, let's see what my chat's got going on. So -7 is the smallest. So here's the question. I'm going to leave that chat open for you. If -7 is the smallest 0, what is its multiplicity? Because it came from this factor. Oh, you're on the right track, but remember, it's not a 0 that's not here. What number did we say would be the exponent if it wasn't shown? Because remember, you don't have 0 of these, you at least got one of those, right? So y'all remember, if there's not an exponent out here, we got to treat it like a 1. So the -7 has a multiplicity of 1. So what's the middle 0? So let's see, the middle 0 would be the 0, right? There you go. And what is its multiplicity? So that is definitely a 5. And I guess that means my largest 0 is going to be the 5. And it has a multiplicity. Let's see, we got that from that factor. So that one had a multiplicity of 2. All right, y'all, let's try another one of those. So this would be like y'all's number 8. So I'm going to have to scoot back up. All right, y'all, f of x equals -3 times x minus 5 squared times x plus 3 to the 4th times x to the 3rd. Now, the thing you got to realize is there's only 3 factors. That -3 does not have a variable, so we don't worry about it at all. We're only worried about the factors that contain the variables. So we got an x minus 5. We'll set that equal to 0. We got an x plus 3. We'll set that equal to 0. And then we got that single x to the 3rd. So we'll set that x equal to 0. So y'all, once again, my single x equals 0. All right, so the other two will add 5. And I get my first 0 is 5. Subtract 3 from the second one. And I get x is -3. So my 3 zeros are 5, -3, and 0. So y'all watch how they answer this one. So they say the 0 5 has multiplicity blank. And then blank is a 0 of multiplicity 4. And then the remaining 0 is blank. It has multiplicity blank. So let's figure this out. The 0,5 has what multiplicity? So let's see, 2. There you go, because it came from the x minus 5. Right, let me see if you got me right. So you're looking at, so blank is a 0 of multiplicity 4. So that came from this factor. We got -3. So good job. -3 is a 0 that had multiplicity 4. And the remaining 0 is the 0. Good job. And it had a multiplicity of 3. Good job, y'all. And that's a trick on it. Just which factor did I get that 0 from? And then what was those exponents on it, okay? But y'all, here's the thing. All of those were factored for us. Next, we're going to have to find zeros, but they're not factored. And we're going to have to do the factoring. So we're going to find the zeros of the function and their multiplicities. So y'all, they're giving me f of x. So this would be like 9 and 10. 9 and 10 are just like this one I'm about to do. So I got f of x equals 3x to the third minus x squared minus 147x plus 49. So we got a 4-term polynomial, and we got to get this factored so that we can find our zeros and then figure out their multiplicities. So to factor this, I'm going to do what we call factor by grouping. Any of y'all take like foundations of algebra class or transitional algebra, you probably would have seen this factor by grouping. But what you do when you got 4 terms like this, factor by grouping means you group these first 2 together and you group the last together. So you make 2 groups of 2 each. So we make 2 groups. Once we got our 2 groups made, we're going to factor out the GCF of each group. Now, the GCF is the greatest common factor. So you take these 2 groups and you factor out the GCF from each group. So I got a 3x to the third minus the x squared. I'm looking for the greatest common factor. Well, it's not going to be a number because that's got a 3 and this only has a 1 here. So we got to look at the x's. I got 3 x's here and I got 2 x's here being multiplied. The most that these two have in common is 2 x's. So that means the greatest common factor for these first 2 terms is an x squared. Now, we got to figure out what's going into parentheses. So if you have a 3x to the third and you take out 2 of those x's, that's just going to leave you a 3x. So 3x's, take out 2, left me 1x. And then that's minus. So here you had a 1x squared. You take out that x squared. Basically, it's like dividing. And an x squared divided by x squared leaves you a 1. So here we factored out the GCF from the first 2 terms. Now we're going to factor out the GCF from the last 2 terms. And y'all, here's something you got to think of. That second GCF gets the same sign as the third term. So what that means, the third term is that negative 147x. That means the second GCF will at least be a negative something. So 147 and 49. This time it's going to be a number that's the greatest common factor. And y'all, I'll tell you a trick on this one. This one's like number 10 actually. So make that a 10. This one, the GCF is always the smallest number because 49 is a factor of 147 because 49 times 3 equals 147. So since 49 goes into both of these numbers, we're going to factor out that 49 as our second greatest common factor. So if you take this negative 147x and divide by that negative 49, you're going to end up with a 3x. And if you take this 49, divide by that negative 49, you're going to end up with a minus 1. Y'all, what do y'all notice about these two things? Well, these parentheses match up. Okay. At this point, your parentheses gotta match up. So if you can get this one, it'll sort of guide you what you got to do here. Okay. So the parentheses match up. So what happens then to finish factoring it? We're now going to factor this into 2 sets of parentheses. The first parentheses, we're going to put the 3x minus 1 because that's common between these 2 factors. So we're sort of going to factor out the 3x minus 1. The second parentheses will be the stuff on the outside, which will be the x squared minus 49. So the stuff inside the parentheses will make 1. The stuff outside will make the other. So at this point, it's factored. Now, these are my factors. There's no exponents on the outside of these parentheses. So we would treat both of these parentheses like they have a 1 to the outside, okay? All righty, y'all. So now I'm going to find my zeros by setting my factors equal to 0. And y'all, let me tell y'all another trick. Y'all see this had a degree of 3. The highest exponent was a 3. That tells me how many zeros I got to get when I'm done. I got to end up with 3 zeros. Well, y'all, here's 1x. That'll give me one of them. There's 2 x's over here. That's going to give me the other 2. So let's find them zeros by setting 3x minus 1 equal to 0 and x squared minus 49 equal to 0. So y'all, this one, we're going to add 1 and then divide by 3. So I get 3x equals 1, and then I'll divide by 3. So that I get x equals a 1/3. So the second one here, I'm going to add 49 and do square roots. So anytime you got an x squared and a number, the easiest thing is to do the square roots to it. So y'all, x squared equals 49. We're going to square root both sides. So square root of x squared is x. Now remember, square root of 49 is going to be a plus or negative 7. So the zeros are 1/3, 7, and negative 7. Now it'll let you use the plus or minus here if you want. So those are my 3 zeros. Each has a multiplicity of, well, y'all, we said right here, if there wasn't no exponents, we put a 1 there. So each of these has a multiplicity of 1. So would y'all like to see one more of these 4 terms real quick? I'll do number 9. How about that? But I ain't gonna lie, 4-term polynomials are tricky. So let's do number 9 so that y'all can see another version. So that one was 10, so I'm gonna do 9. So y'all, 9, and they're similar. F of x equals x to the 3rd minus 9x squared minus a x plus 9. So 4 terms again, we're going to group the first 2 together and the second 2 together. So the first 2 terms, I'm looking for a greatest common factor. And you're going to notice I'm going to factor out the same thing I did on number 10. 3x is here, 2x is here. I'm going to factor out 2x's. So I'm going to factor out an x squared. So if you had x to the cubed, divide that by x squared, that's going to leave me an x minus. Well, if you had 9x squared and you divide out the x squared, the x squareds cancel. All that's left is that 9. So I know when I'm done, the second parentheses has to look like my x minus 9. So y'all remember, second GCF will be negative like the 3rd term. So bring down that negative. So I got an x and a 9 here. They don't have much in common, but they do have one factor in common. If there's nothing else to factor out, we at least got to factor out a 1. So we're going to factor out a negative 1 on that. Okay, so remember, on the second GCF, you got to at least factor out a 1. And watch this. Negative x divided by negative 1 makes that x positive. 9 divided by that negative 1 makes that a negative 9. So y'all look at that. The parentheses match up. So y'all, since these parentheses match up, we sort of factor that out as the GCF of these 2 terms. So remember, the stuff inside the parentheses makes up one of these final parentheses. The second parentheses consists of the stuff on the outside, which is the x squared minus 1. So guess what? No exponents on the outside of these. So at this point, I would treat both of these like they got a 1. And we would set everybody equal to 0 now. Okay, so the first one, and once again, remember, I need 3 zeros because I got an exponent 3. So this is going to give me 1, and then that's going to give me the other 2. So here we'll add 9. and I get x equals a positive 9. This one, I'm going to add 1 and do square roots. So x squared will equal 1, and then we'll do square roots so that x equals a plus or minus 1. So y'all, my zeros are going to be 9, -1, 1. Each has a multiplicity of 1. So on the two problems, 9 and 10, where you got to do this, you're going to get 3 zeros, and they're always going to have multiplicity of 1 on this question, okay? All righty, y'all. So now I'm going to go back to Math Lab and do the last two because they are true, false. So let me go find that. All righty, so let me go. I'm not going next question. I'm going to go down to number 11. And y'all, this is true, false. So let's see. When I gave you the definitions of a multiplicity, I told you if that 0 came from a factor that had an even multiplicity, it was going to be tangent to the x. Then I told you, hey, if that factor came, if the 0 came from a factor with an odd multiplicity, then it was going to cross the x-axis. So look what they're saying, y'all. And this will be for y'all to answer. I got a p of x minus 8 squared, x plus 7 to the 5th. They're saying the graph of this polynomial crosses the x-axis at 8, 0. So you got to figure out which factor they got the 0 of an 8 from. Because remember, the x-coordinate is equal to the 0. We learned that in the last test. So which factor did I get that 8, 0 from? And what is its multiplicity? So on this one, to get a 0 of 8, like that x-intercept, it had to come from the x minus 8 factor. Well, the x minus 8 factor has a even multiplicity of 2. So we said if it was even, it wasn't going to cross, it would be tangent. So this is false. It's not going to cross. It's going to be tangent at 8, 0. So there's 2 false ones. So now here's where the difference on these. On B, they said the exponent 2 is odd. Well, y'all, 2 is not an odd number. So it's got to be D. It's false because the exponent is even and the graph is tangent when they're even. Okay. So y'all know how I just did that. And so y'all figure out this number 12 for me. Y'all got P of x equals x minus 5 to the 9th, x plus 2 to the 6th. Is it true or false that this graph is tangent to the x-axis at -2, 0? Oh, y'all let me get you on that. And so let me show you what I would do to that. -2, 0 means it's got a 0 of -2. Well, to get a 0 of -2, it had to come from the factor that is x plus 2 to the 6th. So that 6 is an even exponent. Okay. And we said if it had an even exponent, it would be tangent to the x-axis. So this one's actually true. So between the two true ones, look what they're doing. So A is true and the exponent 6 is even. That's what we said. But if you look at D, they got true, but look at what they did. They said the exponent 6 is odd. So they'll give you 2 true, 2 false, one with the right exponent, one with the wrong exponent, okay? All right, y'all, then you check that and be done. All right, so let me get it ready for my next one here. All right, y'all, so we'll go back to pad. We're about to learn about the third section. All right, so 8.2, this is the last one of the day. 8.2 deals with graphing polynomial functions. Now, y'all not going to have to graph them. You're just going to have to pick out the graph, okay? But what we got to learn in this section, I'm going to teach you how to change the window on your calculator so that when we do the graphing part, you'll be able to match the graphs to their graphs by making the X and Y axis the same as they got. Because by default, your calculator goes from -10 to 10 on the X's, and it goes from -10 on the Y's, okay? So some of theirs are going to have things going out to 100 and all that fun stuff. So if you want your graphs to look like those, we sort of fix the windows. Also, a lot of these, we can pick out the graph because we can use that in behavior chart we learned a while ago. So the in behavior chart will help you on most of these, but sometimes if they got two pictures doing the same thing, you sort of got to investigate a little bit more on them. But y'all, the first thing this starts with, since we're looking at graphs of polynomials, we try to figure out what is the maximum number of zeros they can have, what's the maximum number of x-intercepts they can have. We all remember, zeros and x-intercepts are basically the same thing. And then we look at what's the maximum number of turning points that a polynomial can have. And there's one number that tells us everything. So y'all, let's look at the first thing. So given a function f of x, the maximum number of real zeros is equal to the degree. Well, remember, the degree is the highest exponent. So that's why a while ago when I was doing them x to the thirds, I knew we would get 3 zeros because the highest exponent was a 3. Okay. Now, that's the maximum number of real zeros you can have. It could have less because remember, sometimes when we did the quadratic formula, we got imaginary answers. So all the zeros might not be real. You might have some imaginary ones also, but this is telling me that the maximum number of real zeros, if they're all real, is equal to that degree. So if the maximum number of real zeros equals the degree, the maximum number of x-intercepts is equal to the degree. Because we said the x value of these x-intercepts was equal to the zeros in the past. So if the number of real zeros is equal to the degree, then the maximum number of x-intercepts has to also be equal to that degree. So the one that's going to be different is the maximum number of turning points. The maximum number of turning points equals the degree minus 1. Okay, so let me show you some examples here. Say I had f of x equaled x squared plus 1. We drew these already. So let's just draw us a nice parabola here. But if this parabola did that, well, 2's my degree. So that means, look at that. The maximum times it can cross the x-axis, or the maximum times that I can have a 0, is 2 times, which is equal to that degree. But y'all look here. It turned 1 time here. So the maximum number of times this one could turn would be 1, which is 2 minus 1. Now, if I had an x to the third, say x to the third minus 1. So let's see what that's going to do. So x to the third might come up, cross the x-axis, turn down, and then it's going to turn up again. So look here. It crosses 1, 2, 3. That's the maximum number it's going to cross that x-axis is 3. And then look here. It turned once here and once here. So 3 minus 1 is 2. So this one turns twice. That's the maximum that these things can happen. Now, why does it say maximum? Because y'all on this graph right here, what if my graph came up, but it turned without crossing the x-axis, then went up? So this will just cross the x-axis once and not all 3 times. But that's just telling me the maximum it can happen, okay? It don't have to cross the x-axis all 3 times, okay? But look, it still has what? 2 turns on it as the max. So as these exponents get bigger and bigger, you're going to have a lot of crazy stuff happening, but this is the maximum that these things can happen. So let's go to 8.2 homework and see what we do with that. All right, y'all. So let me see. There's like 3 of these. So I'll do the first one and then y'all got the next 2. So for me, f of x equals x to the third minus x squared plus 1. Maximum number of real zeros is 3. That's my degree. Maximum number of x-intercepts, well, that's going to be 3 because that's my degree. And then the maximum number of turning points is going to be 2 because that's my degree minus 1. So y'all knowing that, on y'all's little polynomial here, what's the maximum number of real zeros? So 7, that's perfect. All right, how about the maximum number of x-intercepts? So 7 again. And then maximum number of turning points. So 6, perfect. All right, y'all. So same thing here. I think y'all are doing pretty good. So let's see. I'm gonna slide this up. Oh, y'all try this one. What's the maximum number of real zeros on this one? Oh, Hannah, I got you on this one because guess what? This one's out of order. What's our degree on this one? 2. There you go. So you put a 2 in there. So watch them spin into order on y'all. They like to mess with y'all on at least 1 or 2 where they put them out of order. All right, what's your maximum number of x-intercepts? 2, which means your maximum number of turning points is 1. There you go. So y'all, let me show y'all some of the graphing here. So this one, they're saying, hey, use that leading term test. Well, that's that in behavior chart we drew a while ago. Notice the first one's going downhill, the second one's going uphill, the third one, both are down, the fourth one, both are up. So look at here. I got a degree 2. That's even. So I got an even degree. The 1/3 is positive. So y'all, back on that chart, when I had an even degree and a positive lead coefficient, would my picture be like A, B, C, or D? So y'all remember, even degree, positive lead coefficient. And we had 4 pictures we drew. All right. Oh, good. Y'all answered. I was about to pull out the chart again. So D is it, y'all. Perfect. When it was even and positive, both ends went up, and you pick D and move on. Now you could graph that if you wanted to, and you'd get one of them 4 pictures. But y'all, when they're talking about this leading term test, that's all we're looking at. Is that all I got in here, Hannah? Let me see. I was showing 5. Let me look. Oh, I guess some of them dropped out on me. Okay. Oh well. This ain't bad if they're here. It can be tricky if they're not. So y'all look here. X to the 5. That is odd. It's got a positive 1 in front of it. So when it was an odd degree, positive lead coefficient, y'all, that should go uphill left to right. And the only one going uphill would be your A. Now look here. X to the 4. X to the 4th is even. It's got a 1 in front. So both ends are going to go up. But y'all look at this. They got 2 that look similar. I got A and B. Now, do you see under here it says all graphs are going from -5 to 5. That's the X's. They always give you the X's first. So they're saying this is going from -5 to 5 on the X's. The Y values are going from -30 to 70. And then over here it says the scale of the X's is going by 1s, but the scale of the Y is going by 10. So y'all, you see that ends that there's 2 close. So we got to look at the y-intercept. And the y-intercept is going to be that number at the end, that -17. So I got to figure out which one of these looks like it's crossing at -17. And y'all, I really think it's A. Because if these are going by 10, that would be -10, almost to -20. This B here looks like it's less than -10. So we would choose A on that. But you see, I'm going to show you how to set this -5, 5. You can do that stuff on your calculators. So let me show y'all. I'm going to So let me write their numbers down real quick. So that was what, an x to the 4 minus 2x3 plus 10x squared plus an x minus 17. And they're going from -5 to 5, -30 to 70. And then they say the x scale is 1, y scale is 10. Now, sometimes they'll give you the graph with the numbers, but they won't write them out like that. Okay. So I'm just writing out these numbers as they had. And let me go to my calculator now. So on y equals, I'm actually going to put that function in here. X to the 4th arrow down off that exponent and put minus 2 x to the 3rd arrow down off the exponent plus 10x squared plus an x minus 17. Now, to put in those numbers they gave us to make the graph fit, you hit this window button. Right by the y equals is a window button. So hit window. So by default, they're usually on -10 and 10 and all that. So the x's they wanted me to use was -5 to 5. So I'm going to put a -5 enter and then a 5 enter for the x max. The x scale they gave me, the x SCL was 1. So I'm going to leave that alone. I'm going to arrow down to the y max they gave me was 70. Whoops, I missed my y min. Let me go back up. My y min was -30. And then I'm going to go down to y max was 70. So I put 70 in. Now remember, the y scale, they said they want the y's to go by 10. So I'm going to punch in 10. So now I've pretty much got the -5 to 5. X is going by 1. -30 to 70. Y is going by 10. So now hopefully when I graph it, y'all look at that. Perfect. It's almost touching the second tick mark on the y-axis in the bottom. Okay, so we can make our graphs look exactly like theirs by putting our window to what they're using. So y'all look at that graph, and then we'll see. We agree that it is definitely A, right? Because see how that is almost touching the second tick, and B here is above that first tick. So we would pick A and move on. All right, so let's think about this one. Sometimes you can pick them without graphing them because of the leading term. So we got a -x to the 3rd. It's an odd degree with a negative lead coefficient. So y'all, A, B, C, or D, if you're odd degree and you're negative. So let me see what y'all are saying on chat. A, definitely. A, downhill, left to right. So we would pick A and move on. All right, so what y'all figure on this? You got an x to the 5 with a positive 1 in the front. So A, B, C, or D? So D, uphill, left to right. And I'm beginning to think it's just me and you on here. All righty, so look at these ones. I wanted to at least knock out one more of these for you, and then the rest of them are just doing basic graphing and stuff. So on this one, notice this is going from -10 to 10 on the x's. I heard that. I think you're getting everybody's participation today. So this one, I'm going to graph it. Now the X's go from negative 10 to 10. The Y's go from negative 100 to 100. So let me write this down. X minus 5, X plus 5, and then X minus 6. So, and if you notice, these graphs are going everywhere. So let's graph this and change our window and see what we get. So I'm going to go to Y equals. I'm going to clear that out. And I'm going to put in an X times X minus 5 times X plus 5 times X minus 6. All right, so my window, remember, they went from negative 10 to 10 on the X's. And then on the Y's, they went from negative 100 to a positive 100. And I guess I can leave the scale on 10s. It ain't hurting nothing. I just wanted to make sure I got them X min, X max, Y min, Y max. So then I'm going to go hit my graph and see what I get. So if you notice, this one's crossing 4 times. It's crossing over here at negative, let's see, 1, 2, 3, 4. Looks at negative 5 it's crossing. It's crossing in the middle. It's crossing twice on the right side. And it looks like both ends are going up as I head towards those infinities. So it looks like a big W. So let me go look at them 4 graphs. So it ain't A for sure. That's going down. So I'm thinking I'm going with, what are you going with? D, that's what I'm saying. So let me zoom that up just a little. And see it's crossing over here at that negative 5, like we said, the center, and then on the right. So good job. We would pick D, and we would move on. So let me look at one thing here. And yeah, that's all this that's all the rest of this is doing, is just doing a few of those graphs. Oh, let me show you one more thing I forgot. On that calculator, if you want to set it back to the 10 by 10 window in one move, all you got to do is hit zoom and go down to 6, and that'll put it in a standard screen. When you hit enter, it goes back to a 10 by 10, so that when I look at my window, everything's set back on the 10s. Okay, so instead of having to go through the window and putting all that in, if you ever want it back to the 10 by 10, just hit zoom and 6 for standard. Yeah, that's all I do on those. Just hit that and be done with them. All right, y'all. So let's see. That's 8.2. Now, I'm going to send this video out in a little bit. I'm going to send out